grade 9s. Hello. I hope you're well, grade 9s. I hope you're well. So we are picking up this question, this session, this lesson from the very question that we left off from yesterday. Okay. So yesterday we were busy in grade 9. We were busy with the GEC Maths Paper 1. Right? This is GEC Maths Paper 1 week, guys. GEC Maths Paper 1, and we are currently doing the GEC paper written in 2024 and also the GEC paper written in 2023. So we have done questions already that basically look at numbers, the number system. All right, we looked at highest common factor and lowest common multiple type questions, and we are now currently busy. We looked at questions looking at highest common factor and lowest common multiple. We looked at questions that have to do with distance, speed, and time. We looked at questions having to do with direct and indirect proportion, and we looked at questions that have to do with the multiplicative inverse and the additive inverse. Now, if you missed this session, I would really highly encourage you to go to my YouTube channel, guys. There's a grade 9 GEC paper 1 2023 and 2024 playlist that is there. You can check it out. You can watch the part that I just showed you guys. We did this yesterday and it was really fruitful. So for those who are preparing currently for GEC paper 1, you are in the right place. GEC grade 9 paper 1 maths, you are in the absolutely amazing right place. And I would encourage you then to actually go and check out what we've already done in the YouTube channel, because there was a lot that we did yesterday. We also did questions related to financial maths for grade 9. So please, guys, go and check it out. It will be worth your time to go and check it out. I just need to check and confirm for those who are here, grade 9, please let me know, is the internet connection fine? Can you hear me well? Am I clear? Am I not lagging? So that I can start. All right, I just need to get that confirmation. Am I clear? Is the connection fine? Am I not lagging? Okay. Yeah, my name in YouTube, as I said, guys, is Maths is a Game. You can go and check it out. Maths is a Game. Maths is a Game. The link is in the bio, guys. The name of the YouTube channel is Maths is a Game. Please go on there. The link is in my bio. You can go there now and subscribe to the YouTube channel, guys. The YouTube channel is in the bio. The link is in the bio for the YouTube channel. I just need to confirm no lagging, connection is fine, nothing is funny, so that I can proceed and do what we have to do here. All right, let us go. So the question we have here is simplify. Now, in as much as we need to know how to do the questions that I covered yesterday, we also need to know how to do these ones. So here we are told to simplify 6 minus 3 minus 5 plus 9 minus 15 divided by 3. Please don't mind what's happened here, because this here was what this is a question paper that another learner was using last year. So unfortunately it has all this writing. Just don't mind it, ignore it. We need to simplify this, and we are asked, is the answer A 22, B 12, C 16, or D 20? All right, so 6 minus brackets 3 minus 5 plus 9 minus 15 divided by 3. So that is the question, and the answer, is it A 22, B 12, C 16, or D 20? All right, so if we come here, guys, and write this out, 6 minus 3 minus 5 plus 9 minus 15 divided by 3. When we have questions like this, we need to remember Mr. BEDMAS. B means brackets, E exponents. Right, now I know you guys know O, which means off, okay, or order of signs, okay, but guys, when we are in grade 9, E exponents, yes guys, this is grade 9 GEC, D division, M multiplication, A means addition, and S means subtraction. So this is what we know, guys, that whenever we are looking at a question and we have different operations, all right, we need to consider BEDMAS. B means brackets, E means exponents, D division, M multiplication, A addition, and S subtraction. Okay, I hope we are clear here. So if we come and look at this again, then it's very clear that first and foremost, before we do anything, we need to take care of what is in the brackets. So 6 will stay as it is for now. All right, I hope that is fine. Then minus stays like that as well. Then the 3 minus 5 inside the bracket. What is 3 minus 5, guys? We take care of what is in brackets. That's what we mean by order of operation. So the B and the B here, we take care of as far as possible. So 3 minus 5 is equal to negative 2. Then we add 9, then minus brackets minus 15. Now the thing is, guys, this negative 15 does not have an exponent that is greater than 1. The exponent here that we cannot see is 1. So if there was an exponent, we would say brackets exponent and allow the exponent to take care of what's inside. But seeing as though there is no what? There is no particular exponent there. That means that bracket obviously is going to be negative 5. Negative 15 as it is, divided by 3. Okay, so far, brackets sorted. We go on exponents, we don't have any. Division. Now division and multiplication can be taken. We can take care of division and multiplication. So now let's see. This is 6. This is minus. This negative sign is attached to the bracket. So we take the negative sign and we multiply, because brackets mean multiply. Then here as well, negative into negative 15 divided by 3. So we can take care of the division here. Then when we, after dividing negative 15 divided by 3, then we can apply this negative sign. So it doesn't matter if we start with division or multiplication, because division and multiplication, that order is fine. Okay, because division and multiplication are inverse operations. So we can then say 6. What's negative times a negative? It's positive 2 plus 9. Then we have negative 15. Negative divided by negative is also positive 15. Positive 15 divided by 3 gives us positive 5. I repeat, negative 15 times negative 15 gives me positive 15. Then positive 15 divided by 3 gives me positive 5. Now all I have now is what? Addition. So I can add all of these numbers. 6 plus 2 is 8. 8 plus 9 is 17. 17 plus 5 will give me 22. So guys, if I go back now to my options, what option is correct here? Guys, it's very clear the option that is correct. The option that is correct is A, and it's number 22. So that would be my answer that I would select. It is A. Okay, yeah. Okay, I'm looking at what this learner did here. What a misconception. Look at this learner, what he did. He took the negative sign, distributed it. Okay, negative 3, positive 5. But then he took the 6 and attached it to the bracket, which is very, very wrong. And then he multiplied the 6 and the 2 to get 12. And that's where things went south. They went wrong completely and he totally got the wrong answer. And basically selected, I'm sure, the wrong answer from his selection. In actual fact, did the calculation, got negative 21, really didn't work out well, did not get the right answer. So these are things we need to avoid. We need to make sure As I said to you, if you say 3 minus 5 in the bracket, that gives you negative 2. The minute you take this negative and multiply it with negative 2, that is equal to positive 2, guys. So this is 6 plus 2. Okay, very important. Then that's plus 9. This negative times this negative will give you positive 15. Positive 15 divided by 3 gives you positive 5. Then you have addition to take care of, and that leads you to the answer. So let's never make the mistake of doing something that is otherwise. Let's look at this one, number 10. 5 into 3 into 4 minus 5 into brackets. Look at these square brackets. 3 minus 4 brackets 3 square brackets over negative 3 minus 2. They are asking, what is the value of the expression? A, is it negative 21? B, is it 3? C, is it negative 3? D, is it 27? What is the value of the expression? Okay, so once again, what do we see here? We see many operations. So what does that mean? We apply BEDMAS. Brackets, exponents, division, multiplication, addition, and subtraction. So what you see here is 5. These brackets mean multiplication of 5 and 3 and 4. Okay, that is one single term there. Minus separates this 5 into 3 minus 4 into 3 brackets. So we have two terms in the numerator. Then underneath this line, which means division, there is how many terms in the denominator? Negative 3 minus 2. There is 2 terms in the denominator. Negative 3 separated with the 2 by a negative sign. So what we are going to do, we are going to apply BEDMAS. We look at the top, we are going to apply what we know, brackets, and then also apply here brackets. Okay, and we are going to sort out brackets first. There's no exponents, so that's fine. Then we are going to sort out the numerator alone first. Okay, then sort out the denominator alone first, and then after that we are going to divide and see what answer we get. Okay, then we should be able to see an option prevailed, whether A, B, C, or D. So if we go ahead and we go and rewrite this, 5 into 3 into 4 minus 5 into 3 minus 4 into 3 over negative 3 minus 2. Okay, B for brackets means let's take care of this together. Remember the relationship between 5, 3, and 4. Because of the brackets mean multiply. Let's take care of that. What's 5 times 3? That's 15. What's 15 times 4? That gives us 60. Then we come here. The minus 5 stays outside for now. Let's take care of what's inside the brackets. What's 3? Okay, minus, for now we can just say 3. Then what's minus 4 times 3? Let's take care of what's inside the brackets with the brackets. Minus 4 times 3 and negative times a positive gives me a negative. Then 4 times 3 is 12. So we have a negative 12. All right. And this big bracket, remember, was supposed to basically help us distinguish between that bracket for everything and this little bracket there. Now we can just do this. Okay, this big bracket is still this. Okay, over what's in the denominator can be taken care on its own. What's minus 3 minus 2? That gives us a negative 5. Okay, then we have 60 minus. Now this negative 5 is going to wait. What's 3 minus 12, guys? 3 minus 12 is equal to what? Negative 9 over negative 5. We are not done. Remember, still, we can't say 60 minus 5 because BEDMAS does not allow that. We need to first take care of the brackets. So the 60 weights, then we say negative 5 times negative 9. And negative times a negative gives us a positive, while 5 times 9 gives us 45 over what? Negative 5. Then we say 60 plus 45 in the numerator, that gives us 105 over what? Negative 5. Then what's 105 divided by negative 5? That's where you guys come in. You punch into your calculator if you need to, but the answer there, guys, is a negative what? Positive divided by negative is a negative, and then 105 divided by 5 gives us 21. So our answer is a negative 21, and that is basically what we basically get for our answer. So if we go now and check our options, is it A, B, C, or D? Definitely our answer is A, and negative 21. So therefore we can just say A. In the answer script, as I said to you, you will be given an actual booklet where you can write the letters for your answers. There you will write an answer that is A. Okay, remember guys, this is just a previous question paper 2024. We are just using this to sort of like give us an idea of how we ought to approach these questions. So on a rough piece of paper, you are going to have that rough piece of paper. If they don't give you the rough piece of paper when they hand out scripts, ask the invigilator in your school to please give you a piece of paper, a rough piece of paper, so that for questions where you see there is some working out that needs to be done, please make it a point that you do that working out. If in some situations your calculator can sort of like help you out without having to do the working out, guys, please make it a point. You take your calculator, you do punch in those things and make sure you punch them in correctly so that you can see if you get the answer. Maybe if someone else is in the live, if you have your calculator, see if you do that fraction option and you punch in all of these values as you see them, and then press equal. Does it give you negative 21? Does your calculator give you negative 21? Because if it does, then that's probably one way you can shortcut the process, because you don't have to waste time doing this calculation on the side when you can simply use your calculator to basically get the answer and then move on to the next question. That way you save time. But guys, if you don't want to be doing that, then please, by all means, do the working out on the side and then go and select the right option. So for those that are coming in now and you missed what I just did, please guys, I'll be uploading this. You can rewatch it in the YouTube channel. Please, 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 because I don't really have that much time. So let's look at number 11 now. Number 11. Another question that is similar to this one, but now we have roots, square roots, and exponents. Okay, remember guys that part of the guidelines that are there for GEC, there are also questions around this that we did in the year that we also need to know how to do. So we need to evaluate this. In other words, simplify this. Is the answer A 1, B 5 over 3, C negative 4 over 3, or negative 1? That's the $1 million question. So we are going to also write this out and see what we actually get when we answer this. Remember, if it was not multiple choice, and let's say this question came out and we were supposed to answer it, then we would have to step by step show what would be the answer, because evaluating something means we need to show our steps in simplifying this thing. Okay, so I hope you understand that, my grade 9s GEC learners, okay, that are writing on the 13th very soon. So let's see if we do this, what happens. So we take it piece by piece. Once again, we remember who? BEDMAS. Brackets, exponents, division, multiplication, addition, and subtraction is the order in which we operate. So let's start here. The cube root of 125. Guys, this is simple. Take your calculator, punch this in, and you say the cube root of 125. You should get your answer, which is 5. Okay, why do we take care of this alone? Because it is a separate term alone. minus 3 squared, that's another term alone, plus 0, that's another term alone, plus 1, that's another term alone, over negative 4 is a term alone, plus square root of 121 is a term alone, minus cube root of 64 is a term alone. So brackets, there are no brackets. So immediately we apply exponents. Now under exponents, there are roots as well. Okay, our roots also qualify as exponents. Okay, so 5 is the answer for the cube root of 125. You guys will know that the cube root of 125 is like saying 5 to the power 3. Okay, then if you have a cube root, this is like saying, if you remove the cube, you say 3, which is in the numerator, over this 3, which would be written in the denominator. And then that simplification would lead you to the answer of 5. Okay, that is something that you should know. So how did you get 5 to the power 3? You take 125, you press 125 is equal to shift in your calculator, then fact. And when you do this, you get 5 to the power 3. Then obviously, when you apply the cube root to 5 to the power 3, this 3 belongs in the numerator. You remove the cube root, this 3 belongs in the denominator, and 3 divided by 3 leaves you to 1. So the answer is 5. But we don't have to actually show this step here. That's just something for you to understand and know. All right, so cube root of 125 is 5. Negative 3 squared. This negative is on its own. What is 3 squared? It is 9. Plus 0 plus 1 in the numerator. Okay, so far in the numerator, we've sorted out the exponent or the root part. Let's go to the denominator. Negative 4, what's the square root of 121? That is 11. Minus the cube root of 64. The cube root of 64, right? Okay, so this here, if you put it in your calculator, you say the cube root of 64, you will get the answer 4, right? Then, my grade 9s, you look at the numerator and sort out the numerator on its own. What's 5 minus 9? That's negative 4. Plus 0 is negative 4. Plus 1 is negative 3 over. You have negative 4 plus 11. That is 7. 7 minus 4, that is 3. Then what's a negative divided by a positive? That is negative. And then 3 divided by 3, that is 1. So that basically now, guys, is what we would do as a grade 9 learner for paper 1 if simplifying this thing. Now we got negative 1 as our answer. I hope that makes sense. We applied BEDMAS in the numerator, we applied BEDMAS in the denominator, we got these individual answers and terms, then we added and subtracted what is in the numerator alone, added and subtracted what is in the denominator alone, and then we used this line, which we know is a division line, to divide the top answer over the bottom answer. Negative divided by positive gives us a negative, and then 3 divided by 3 gives us 1, so the answer is negative 1. So if we come to our options, which option would we choose? A, is it 1? B, is it 5 over 3? C, is it negative 4 over 3? Or is it D, negative 1? We can see clearly the rain is gone. D is actually equal to negative 1. So we would select D as our option. We would write this answer, this letter in our booklet, and that would be us getting full marks for that question. Here's another one. Okay. Initially looks scary, but it is so easy. Not scary at all. It looks scary, but it's not scary at all. Those who are in grade 8 paper 1, please go to my YouTube channel. I've done paper 1 type questions. You can go to my YouTube channel. The link is in my bio. The link is actually Maths is a Game. The link is in my bio. You go and copy the link, you paste it on the Google search engine, and then you search for my YouTube page. You will find it. There's a playlist. Go to the playlist tab. On the playlist tab, you go and check out the grade 8 maths November paper 1 playlist. You'll find some videos there that I've done of previous live lessons for grade 8 maths paper 1. You can watch till your heart's content. I've done past papers for grade 8 maths paper 1, and you can revise those there. But for now, even this question as a grade 8 learner, this would be applicable to you, even though this is a GEC question, because grade 8 and 9 are relatively the same. Okay, so grade 9, let's look at this question. The cube root of 27 plus the square root of 50 over 2 brackets to the power 2 over 4 squared minus cube root 8 over the cube root of, the square root of 49. Is it A 16, B 4, C 1, or D 49? Okay, so let's come to the question and check it out one by one. Remember, we must think of BEDMAS when we do this. Brackets, exponents, division, multiplication, addition, and subtraction. So everything here is in the bracket, which is to the power 2. So we come inside the bracket and we start looking at what we have there. So here we have a line, the cube root of 27, we need to find on its own. Yes, this is GEC. The cube root of 27 is what? It's 3. That's the answer there. 3 times 3 times 3 will give us 27. So the cube root of 27 is 3. Plus, let's sort out the square root of 50 over 2. 50 divided by 2 is 25. All right? 50 divided by 2, guys, is what? Is 25. Okay? Shlochimesh, you can go to my YouTube channel as I have explained to you. You want grade 8 paper 1, please, you need it urgently. Go to my YouTube channel. My YouTube channel link is in my bio. Copy and paste the link in your Google search engine, press search, then go to my YouTube channel. Then you go to the playlist tab. Go to the playlist tab. Click on the playlist tab. Go to grade 8 maths. There's some past November videos that I did that you can watch there if you want. But on my TikTok page, there are some papers that I've posted there for grade 8 maths paper 1. You can always watch those, check those out and see those questions. So 50 divided by 2, guys, is what? Is 25. The square root of 25 is what you would have there. I hope that makes sense, because 50 divided by 2 is 25. Okay, underneath that, what's 4 squared? 16 minus the cube root of 8. What is that? It's 2 over, what's the square root of 49? It is 7. All right, yeah, let's do this one bit at a time. Let's go back. Equal to, what's 3 plus the square root of 25 is 5 over, what is 16 minus 2? It is 14 over what? Over 7. We put everything in the bracket squared. What's 3 plus 5 in the numerator? It is 8 over 14 over 7. The whole thing what? The whole thing squared. I hope you guys see what we have here. We have 8 over the 14 over 7. So let's look at the 14 over 7. What's 14 divided by 7? 14 divided by 7 is 2. The whole thing squared. What's 8 divided by 2? It is 4. The whole thing squared. What is 4 squared? It is 16. That's the answer we get, guys. Step by step, you saw what I did. Back to the top. I saw that it looks so scary, this problem, but it is so simple at the same time, because all you need to do in your head is you need to check what do we have inside the brackets. Okay, we have the brackets and the exponent, right? But remember, BEDMAS says we start with what is inside the brackets. So what is inside the brackets? What do we see? The cube root of 27 in the numerator plus, which separates these two and the square root of 50 over 2. Cube root of 27 is 3. Square root 50 over 2. 50 divided by 2 is what? Is 25 inside the square root. 4 squared is 16 minus, what's the cube root of 8? It's 2. Square root of 49, 7. Look at this top part. What's 3 plus? The square root of 25 is 5. What's 16 minus 2? It's 14. And then the 7 is there. What's 3 plus 5? It's 8. 14 is there. 7 is there. What's 14 divided by 7? It's 2. What's 8 divided by 2? It's 4. We apply the square to what is inside the bracket, because after sorting out what is in the bracket, we can now apply the what? The exponent. What's 4 squared? It is 16. Very straightforward, guys. Please, when you see something that's so complicated, please don't panic. Calm down, breathe, and then relook at the question. You will see that the simplicity is always contained in you being able to check. In this numerator, how many terms? There's 1, 2 terms. Can you sort it out? Yes. Can you sort that out? Yes. How many terms? 1, 2, separated by this minus sign. Can you sort that out? Yes. Can you sort that out? Yes. In this here, what is that? It's the square root of 49. What is it? Can you sort it out? Yes. Can we sort that out? Yes. What is it? It's that. What's 16 minus 2? It's that. Can you sort that out? Yes. What's this divided by that? That's that. What's this now divided by that? It's that. And then you square it, you get that answer. So it's very simple. We can now select our option. The option is A. Looks difficult in the beginning, but we soon realize that it is easy peasy. Okay, now we are moving from the world of roots and square roots into the world of exponents. There, our laws of exponents need to be remembered. Okay, our laws of exponents need to be what? Remembered. And when we remember our laws of exponents, then it becomes very easy how we answer the question, because recalling those laws is everything. We can see here 13 is exponents, 14 is exponents, 15 requires our understanding of exponents, so it becomes easier. So Eva Lerato, thank you so much. You can see Eva Lerato is on the money there. 3n cubed times 2n squared. I'm seeing this one. We can see very easily, guys. GEC learners math paper 1 grade 9. That one should be quite simple. Taylor is also saying 6n to the power 5. Okay, Taylor and Eva Lerato are in agreement that the answer is A. Neurosurgery is saying the answer is B, which is very, very disheartening that neurosurgery would think it's B. And why do you think neurosurgery is saying it's B? It's because neurosurgery has a misconception of thinking that when you are multiplying 3 and 2, you are basically saying 3 plus 2, which is very wrong. We don't add 3 and 2 here. We are multiplying. But the law of exponents says when you are multiplying same variable, n and n bases, what do you do to the exponents? Those are what you add, but the numbers you multiply. So laws of exponents, guys, please let us not forget these. Okay, when you are multiplying same bases, we know that we keep the base, we add the exponents. That's law 2. Law 1. Law number 2, when you are dividing, you subtract the exponents when you have same bases and you are dividing. Law number 3, if you have a base raised to an exponent and then outside raised to another exponent, what do you do to the exponents? You multiply them. 4, a m b to the power n all raised to the power p. If you have different bases and you are multiplying those bases and they are both respectively raised to exponents, we apply the exponent to everything. The sign of the bracket, we apply the exponent to the sign, we apply the exponent to the number, we apply the exponent to the letter or to the variable. So this to the power p, okay, we would apply and say m times p. This bn b to the power n, we'd apply the exponent p and multiply n times p. This is also applicable obviously to what? To division of different bases when raised to a certain exponent. We know this is a to the power m times p over b to the power n times p. Okay. 6. Let's say we had a negative exponent. Okay. We know that this will be 1 over a to the power n. What happens? Whenever a base is raised to a negative exponent, we take that base, we move the position of the base from the numerator to the denominator. The coefficient that is there gets left behind in the denominator because the 1 does not have a negative exponent that it is raised to. So the 1 gets left behind, the a goes to the denominator, the exponent changes sign from negative to what? To positive. That's very important that you guys note that. It is the same as if we had 1 over a to the power negative n. The answer would be a in the numerator raised to the power n with now a positive exponent, not a negative one. So this is an important rule we need to know when it comes to exponents, that for bases raised to negative exponents, we simply change the position of the base. If it was in the numerator, it goes to the denominator and the sign changes. If the base was raised to a negative exponent in the denominator, it changes its position from denominator to the numerator and the exponent sign changes. Okay. Then we need to also know that any base raised to the power 0 is equal to 1. Additionally, for your own enrichment, if ever you find yourself in a situation where there are 2 bases divided and they are raised to a negative exponent, you can simply swap the numerator and the denominator. Then the exponent sign changes to positive. This is everything related to this law, the changing of positions of bases when raised to a negative exponent, and the change of the sign of the exponent from negative to positive. So here in this situation, you can simply swap around the numerator and the denominator and raise it to a positive exponent. These guys are the fundamental laws we need to be aware of. Then do not do this particular nonsense here. Don't ever think that if you have a plus and a minus sign between 2 terms and you have an exponent, that you can do this. This is nonsense, guys. We don't ever do this. Never. This is absolutely wrong. Wrong. We do not ever multiply the exponents if there's a plus and a minus sign in between. So for addition and subtraction, we don't do this. Never. This is absolute rubbish. Okay? But when there's division between the bases, you can do it. Apply the exponent to the numerator and the denominator. If there's multiplication between the bases, you can apply the exponent and multiply. All right? But when there's addition and subtraction, rubbish. We don't ever do this. Okay? So come back here. 3n to the power 3 times 2n to the power 2. Very straightforward, guys. Okay, so when we multiply, okay, yes, these are the laws. I basically will summarize the laws for you guys so that you know what you are doing under laws of exponents. When you get to questions in GEC and you are doing laws of exponents, you are applying the laws, you need to apply them knowing what you are doing. So here, please guys, 3n to the power 3 times 2n to the power 2. We actually multiply, obviously, but we apply our understanding. We multiply the signs, if there are different signs, followed by the numbers. We multiply, followed by the letters. So S and L, you usually see this in the movies, all right? But please, guys, in the movies, This means very bad things. In maths, when you are multiplying things or dividing things, you must always apply the multiplication of the sign S, multiplication of the number N, multiplication of the letter L. Okay? Okay? Yeah. So please, yes, noted, guys. Okay? Okay, so this is like, for instance, if I had an example like this, a plus b, the whole thing squared, you know that all you need to do, how many a plus b's must you actually open? You must open 2 brackets of a plus b. Then what do? You apply FOIL. Okay, FOIL. You know, all right? If it was a plus b to the power 3, obviously you do the same. If you can add the like terms, you add those like terms, then you apply the exponent. Okay? So hopefully you understand this, guys, and it makes sense. So noted the nonsense and what you need to do when faced with that situation. So if you apply S and L here, positive times a positive is a positive. Okay, sign is taken care of. Then we move on to the number 3 times 2. What's 3 times 2? It is 6. Then we move on to the letter. N to the power 3 times n to the power 2. That's n to the power 3 plus 2. You see? So the final answer is actually 6n to the power 5. So that's why you can actually look at this by inspection. Okay? Look at this by inspection. Guys, like I said, the YouTube channel is also called Maths is a Game. Okay? 5 to 7. That's what basically is. You will see the Maths is a Game emblem, but it actually has a white background. You'll see Maths is a Game, let's play, and it has a white background, the profile picture. The link is in my bio. Okay, link is in bio of the YouTube channel. So what you need to do is you need to copy the link, then you paste it where? You paste it in the Google search engine. So you go to Google, you paste the link there, paste it in the Google search engine, then what you do is you press search. Then it should lead you to the YouTube channel. You will see it. I think I just went over what we call 2,000 followers. It's just over 2,000 followers that I got because you guys have been following nicely. All right. So go there. You can go to my playlists there. I have playlists, guys, for grade 8, grade 9, grade 10, grade 11. Go check out my playlist. You click on the playlists, okay, for grade 8, 9, 10, 11. If you are in any of these grades, and you go and check November paper 1, November paper 2, November paper 1, November paper 2, GEC 2022. I have 10 videos that I did of live sessions of GEC 2022. You can check those out. You can watch them, rewatch them at your own time and your own pace. Grade 10, I did paper 1, maths paper 1, right? Functions, algebraic expressions and all of that. Grade 11, I think paper 1, things done there. On the playlist as well, you can find some of my other videos where I did topics for the respective grades. You can check those playlists out as well. Right? So that is basically about the YouTube channel. Okay, I'll be uploading this as well on the YouTube channel. So if you've missed something, you can rewatch it. This is part 2 of this GEC paper that we're going through. I did part 1 yesterday, question 1 up until question 10. Now we are busy trying to get from question 10 up until 20. We are going between paper 1 2024 and paper 1 2023, and we are looking at the types of questions that were asked then, so that we can have an idea of what to expect in Thursday's paper. Or is it Friday's paper? Wednesday's paper. Yeah, Thursday's paper. So the answer is 6n to the power 5. So which option would we choose? Definitely we would choose A, guys. Not a doubt. A is the answer. Let's move on to 14. 14, simplify. Negative 2x squared y to the power 3. Be careful, guys, when doing this question. Be careful. Okay? Is it A? Is it B? Is it C? Or is it D? Okay? And look at this person who was answering this question. He said negative 8x to the power 5y to the power 3. So the person that answered this question said this is the answer. How sad. How sad that he thought the answer is C. So that means this person did not know their stuff. All right, hopefully you know your stuff. Okay, you know the laws, you can apply the laws. So which one would it be, guys? Okay, I see people saying A. You are Chila says it's A. What is everybody else saying? Okay, B. I see B from Alicia. Felicia. Precious Ching is saying B. Jovis is saying B. Praise is saying B. Dante is saying B. Lonique. King Legend vibing with Vukari. Is it Vukari? Yeah, vibing with you, saying B. So guys, I see most of you understand. Indeed, the answer is what? Is B. And why is that the case? Just something else to note here, guys. Whenever we have a number which is negative that is raised to an odd exponent, then we know that the sign will be negative. But whenever we have a number inside the bracket and it's raised to an even exponent, meaning this n is an even number, then obviously the sign changes to positive. Okay, remember when I said to you guys, when you actually apply BEDMAS, brackets exponent, you apply the exponent not only to just the what, the number or the letter alone, you apply it to the sign S, you apply it to the number N, you apply it to the letter N. S and L. You see, I told you, you see this in the movies. Now you need to see it in maths, but it does not mean what you see in the movies. If you ever see this in the movies, it's a good time to switch off that movie and go and do some maths so that you can get better and better in your maths. So sign, the exponent is odd. When you apply an odd exponent to a negative sign, what sign do you get as the outcome? It is a negative sign. Here, guys, you see, odd exponent applied to a negative sign means you have a negative number. But remember, this exponent needs to be outside of the bracket with a negative thing. That's why we say the answer is negative. Okay, then you apply the so the sign is done. Now we apply the odd exponent to 2. What's 2 to the power 3? That gives us 8. Does that make sense? Then you apply the exponent to the letters now. So you apply it to the x, which means 2 times 3. You apply that exponent to the exponent of y, which is 1 that you cannot see. It's 1 times 3. I told you guys, it's like 1. It's like the Holy Spirit. You can't see it. It's like it's invisible but present. Angels, invisible but present. So final answer, negative 8x to the power 6, y to the power 3. That is the answer. Negative. So those who said B, you are spot on. Okay. Everybody else that said something else, you are sadly wrong. Let's go on. Evaluate 2 to the power negative 2 times 6 to the power 3 times 3 to the power negative 2. A, B, C, or D. So let's write this down. 2 to the power negative 2 times 6 to the power 3 times 3 to the power negative 2. We need to evaluate that. Vibing with Vutlari is already saying the answer is A, 6. All right, what is everybody else saying? Okay, look at this learner. Hey, these are funny things. Imagine this learner was like, I'm writing GEC and this is what I'm going to write. 2 to the power negative 2, he interpreted it to mean this. What nonsense. What nonsense. 6 to the power 3, okay. Then 3 to the power negative 2. Look, he interprets 3 to the power negative 2 to mean this. What nonsense. This is nonsense. Okay. Right. So let's go now and check what we would do. Okay, I see your answers. Precious. I see your precious answer vibing. I see your vibing answer there. You are vibing. Eh? So 2 to the power negative 2 is a base raised to a negative exponent. Remember, what did we say about bases raised to a negative exponent? Change the base from the numerator to the denominator. The exponent sign changes to positive. So 2 to the power negative 2 is actually equal to 1 over 2 squared. Times. What's 6 to the power 3? Well, 6 to the power 3, guys, obviously that is equal to what? That's equal to some answer. We can leave it in exponent form for now. Times, what's 3 to the power negative 2? It's 1 over 3 squared. Okay, so maybe someone else would do it this way. Then they would say 1, what's 2 squared? 1 over 4. What's 6 to the power 3? Now someone else, like I said, depending on who you are, would say 216, and then what's 1 over 9. Now you grab your calculator, very easy. So you have 1 times 216 times 1. This is like saying 216 over 1. 1 times 216 times 1 is 216. 4 times 1 times 9, that is 36. Grab your calculator, guys. You punch this in. You should get an answer of what? What's 216 divided by 36? You get an answer of C. Very simple, very straightforward, to the point. Okay. Now I'm just thinking of someone else who would look at this a bit differently. They have 2 to the power negative 2. They can see it's multiplied by 6. So what they do is they break up the 2 and the 6, and they write 2 times 3 raised to the power 3. And then they write 3 to the power negative 2. They keep everything like this, not a problem. 2 to the power negative 2 times. Now you apply the exponent to the 3 to the 2, it's 2 to the power 3. Times 3 to the power 3. What do you get, guys, there? You get 3 to the power 3 times 3 to the power negative 2. That's someone else. They're looking at this question and they're like seeing this. Then after that, the base 2s, these are the base 2s. The base 3s, these are the base 3s. So what do you do when you are multiplying same bases? You keep the base, you add the exponent. Okay, so this would be negative 2 plus 3 for base 2. Okay, then for base 3, this would be 3 to the power 3. 3 plus minus 2 plus minus. Positive times a negative, it's like same thing as saying 3 minus 2. Then you get 2. What's 2 minus negative 2 plus 3? That's 1. What's 3 minus 2? That's 1. So in other words, you have 2 times 3, which is actually equal to 6. That's someone else who's looking at the very same question and they get the same answer as that. If you go to your calculator and you say 216 divided by 36, you should get 6. Now someone else who's doing this question would be probably like, I'm just going to punch this into my calculator. Maybe when you punch all of this into your calculator, you get the answer, and that's enough. Remember, you are at the end of the day wanting just the answer. Okay, so you do sometimes the rough work because you want to confirm the answer. All right, and remember, in the GEC paper, when you do the multiple choice, you are not going to have space there to write down these steps. You need your rough paper on the side to be able to check and confirm your answers. Or you can simply use your calculator, punch this in, and the answer should pop out. Can I confirm? Those who have a calculator with them, when you write this in your calculator, do you actually get the answer, which is A, which is 6? Because if you do, then that's just the way you would go about answering this question, because you will be marked for the correct answer, not for your steps, because there is no actual place where you are writing to show steps. Why am I doing this? So that we know what we ought to do when we are answering questions like this under any other situation. That is why I am doing this. And I want to also help you guys recall what you have done during the course of the year. Okay, if we are good here, let's turn over the page. Hey, look at this one. Simplify. Okay, negative 3. Let's look at what negative 3 brackets x to the power negative 1 y squared raised to the power negative 3 times xy to the power, all of it to the power negative 5. Is it A? Is it B? Is it C? Is it D? All right. Okay. So we are going to also do this step by step so that we can see how our answer comes about. You see? Yeah. So remember, with questions like this, we must remember Mr. BEDMAS. Mr. BEDMAS ought to be remembered. Mr. BEDMAS or BEDMAS needs to be remembered. So I see, okay. So make sure we first write out the question. So -3. So what we have here, we have no plus or minus sign in between the terms. So that means this is one term. Okay. So according to BEDMAS, we take care of the brackets and the exponents. Brackets and the exponents. That's what we start with according to BEDMAS. So -3, please wait outside until I can sort out what's inside the brackets with the exponent. So let me apply the exponent immediately to each variable that's here. I can do that because this law allows me to do that. You know, the relationship of x and y is multiply, so I can apply the exponent. Okay, s and l, there's no, the sign, we don't have a sign there of the coefficient. It's positive, well, it's actually positive, but then obviously we are applying the negative exponent to just the variables because the number is 1, the letter is positive. It does not really have an effect on us applying the negative exponent to the number 1 and the positive letter. So we just simply say apply the negative exponent to the letter. So we get x to the power. We multiply these two. Remember, what's -1 times -3? That gives us +3. We apply the exponent multiplication. 2 times -3, that's y to the power -6. Okay, we keep that there. Times xy. The relationship with x and y is one of multiplication, so the law can be applied. We apply the exponent, multiply. So we apply the exponent, multiply, we get x to the power -5, y to the power -5. So far, are we good? I hope we are. Next step. This has a relationship of multiply. So -3, if we multiply -3 with that, we remove the bracket, that's -3x to the power 3y to the power -6 times x to the power -5, y to the power -5. Okay, now at this stage, I am going to multiply this with that, applying s and l. Multiply this with that, multiply the sign. The negative times the positive of this. Remember, there's an invisible one here that is positive, that is before the x. So negative times that positive gives me negative. So sign has been taken care of. We move on to the number. 3 times the one that I cannot see is 3. Number has been taken care of. Go to the letter. X to the power 3 times x to the power -5. That's x to the power 3 plus -5. Okay, but I know positive times a negative gives me a negative. Okay, so in the next step, I'm going to resolve that sign and get the answer. Then y, with that y, we multiply y to the power -6 plus -5. I'm not done. I move on. This is -3x. What's 3? What's a positive times a negative? That's 3 minus 5. What's a positive times a negative? That's -6 minus 5. I have -3x. What's 3 minus 5, guys? It is -2. What's -6 minus 5? It is -11. And remember, guys, this variable is exposed to a negative exponent. This -3 is not exposed. It is not affected by this negative sign. Okay? This variable exponent is exposed to this negative sign. So what does that mean, guys? We apply that law that has to do with a negative exponent. What did we say? When a base is raised to a certain negative exponent, the base changes position and then the exponent changes to positive. So what we see here is that this -3 remains in the numerator alone. This x and this y are going to go to the denominator, both of them. So that means the x, since it's raised to a negative exponent, goes to the denominator, then it gets raised to a positive exponent too. This y is also raised to a negative exponent 11. It goes to the denominator. It gets raised to a positive exponent 11. So this, guys, here is my final answer. Okay. So the answer, guys, that is the answer for real is actually C. This is the answer. Okay. Negative 3 over x squared y to the power 11. So the answer that we should basically choose there is the beautiful answer C. Okay, so this is grade 9, guys, but applicable to grade 8. Okay, and if you're in any other grade and you are here, well, welcome. Okay, okay, so yes, that's how we simply do this, guys. The maths is absolutely mathsing. It is straightforward. All right, guys, maths is a game. Maths is a game. It's like my channel says. Okay, we play to win. We don't play to lose. We win all the time. Why? Because we know all the strategies. We know all the game plans. All right, we know all the strategies to apply so that we get to the winning answer. We never lose. We just win all the time, guys. Losing is not part of the equation. That's why 100% is such a possibility when we do maths. Okay, yeah. I usually say, if you do what you need to do, you do your part, you will see how easy maths is. Let's move on to the next question. If you look at this, okay, you think that, it's so difficult, it's so big, look, and then I look, I'm like, guys, all we need to apply is the strategy. Okay, so we have y squared plus 1 over y to the power negative 2. Very important that we understand that in our numerator we have how many terms? 2 terms, because the plus sign separates the y squared and the 1 over y to the power negative 2. Then in the denominator, how many terms? This is y squared times y squared. This is 1 term. Okay, so I hope we can actually simplify this, and then there's an exponent negative 2 on the outside. They are asking, is the answer A, 4y to the power 4, B, y to the power 4 over 4, C, negative 4y to the power 4, or D, negative y to the power 4 over 4? So which one is it? Jovis, I see, is saying the answer is 17B. Okay, which means Jovis is like a calculator. Jovis is just working out these things like the speed of light, or Jovis has the memo open in front of him and he's just reading the answer, or he's done it before and it just is easy, ka-peasy, ka-easy, ka-deasy, ka-neasy. Okay, all right, so let's go and apply our laws, because our laws, they help us out so nicely. Someone will think, this is so complicated, so difficult. So it's not, guys. Let's first look at what we know. We apply BEDMAS. So what we are going to do, we know most, when there's different operations, we think of BEDMAS. Brackets, inside the brackets, what do we have? So for now, the exponent can just chill here. Let's look at what's inside. Let's simplify what's inside. It will make life easy, especially because in the numerator, what do we have? Y squared plus y over y to the power negative 2. So if we look at y squared first, plus, this is 1 over y to the power negative 2. I learned a law which really helps me out. Remember, I said to you guys, if a is raised to the power negative, the a changes position from numerator to denominator, and his exponent changes to positive. Vice versa, if 1 is over a and it's raised to a negative exponent, this a is in the denominator at the moment. So you move the a to the numerator, the exponent changes to positive. So this law here, this rule is very important, this definition. Please, guys, negative exponents. So we can take this 1 over y to the power negative 2 and write it as y squared. Do you see that? This 1 over y to the power negative 2, what happens? The y is raised to a negative exponent. So what happens to the y that's raised to a negative exponent? It changes position, it goes to the numerator. And then the sign of the exponent changes to positive. Thank you so much. Tebucho Tichole for the rose. I love you. I really appreciate what you've done. So this y raised to a negative exponent gets moved to the numerator. And then it joins that one that is there. All right? And it becomes 1y squared. And then 1 gets left behind in the denominator. But guys, look at this. When you have y squared like this, something that you guys don't realize is that there are invisible entities that surround the y. This is why, guys, I believe in God so much. Maths has taught me to believe in God. You know, you can think that you are alone, but angels and God, one there, you can't see that one. One in the denominator, you can't see that one. Y squared is actually 1y squared over 1 if you are going to write it as a what? As a fraction. That's what y squared is. You are surrounded both in your left and where you're not looking. You are surrounded by heavenly help. You are never alone, guys. You are never alone. It may feel like it. When we write y squared alone, it feels like the y squared is alone, but it's not. It's got a 1 there. It's got the 1 there. The one and only true way is there to protect and surround. So y squared O plus y squared is what we can then write in the numerator. Then we have y squared times y squared. That's fine. Y squared times y squared, all raised to the power negative 2. Do you see how simple now this thing becomes? Then still we are looking in our numerator. We now have like terms. Hey, like terms. Like terms are easy, guys. Y squared plus y squared is equal to what? When we are adding like terms, we keep the variable that is the same. It's like we are wearing the same jersey in the same school. One learner from Tobachale High School that's wearing the uniform, plus another learner from Tobachale High School. When you add those two learners together, they are wearing the same uniform. You have two learners from what? From Tobachale High School. Does that make sense? That's what you do when you are adding and subtracting like terms. You keep the uniform. You add the learners. You keep the uniform, y squared. You add the learners. So the answer is 2y squared in the numerator. Then we are coming here. Chini, this is multiplication in the denominator. Y squared times y squared. When you are multiplying same basis, what do? We keep the variable. We add the exponents. So that means 2 plus 2, that it is. Or raised to the power negative 2. Then you guys will remember I said to you, when you have a fraction, it's raised to a negative exponent. What can you do? You can swap the numerator and the denominator, and what happens to the exponent? It becomes positive. You see, these laws are coming into play. Now, imagine I don't know these things. Then I'm destroying myself. It's easy when you know your stuff. So what I can write is y to the power 4 over 2y squared. What happens to that negative exponent? It becomes positive 2. Hey, this guy is making life easy for us. Easy for us. Maths is a game. It's very easy, this maths. It's a game for sure. When we know the rules and we know how to play, we know the strategies. Easy capiz. Then, now where are we? We are here now. We have a numerator and a denominator. They are raised to different exponents. So now we can apply this guy. Apply the exponent. We multiply. Okay? We apply the exponent. We apply that exponent to the sign, to the number, to the letter. We apply the exponent to the sign, to the number, to the letter. So in the numerator, we are going to apply the exponent. There's a positive one that's there, but the exponent that is positive 2 applied to positive 1 does not really change 1, but then it changes the exponent. What's y to the power 4? We multiply 4 times 2, that's y to the power 8 over. We apply the exponent in the denominator as well. Remember, when you apply the exponent to the denominator, we apply it to its sign, which is positive, and even exponent to a positive sign remains the sign being positive. We apply the positive exponent even to the power 2 to the power 2. Then we say y to the power what? 2 times 2, that gives us 4. So we have now y to the power 8 over 2 squared is 4y to the power 4. Then we simplify. When we simplify, we have 1 over 4. Very important. 1 over 4. There's a 1 coefficient, there's a 4 there. That's y to the power 8 divided by 4. What happens when we are saying y to the power 8 divided by 4? When we are dividing same bases, we keep the base. In the numerator, we subtract the exponent. Then what does that give us? It gives us 1 y to the power what? 4 over 4. Okay? Okay, and remember, the 1 is there. But you know what? Just like God or the Holy Ghost or the Holy Spirit or angels, invisible, unseen, ever present. Does that make sense? Invisible, unseen, ever present, they are there. They are always there, even though we don't see them. So that basically then leads us to the answer. Y to the power 4 over 4. So our answer is B, guys. It's B. Laura, thank you so much for the rose. I really appreciate it. Laura and you. Ngos. Tango. Thank you. Okay. What if y to the power 8 was at the bottom? Let's just for a moment think about this. Karen is asking, what if the y to the power 8 was at the bottom? Well, and let's just imagine that in this situation it was 4y to the power 4 over y to the power 8. Let's just say that was the situation. Okay, that means 4 divided by 1, that is 4. Then we would say y to the power 4 minus 8, Laura. Bases divided that are the same mean we subtract the exponents. So this 8 is 4 minus 8 in the numerator. Then we write the answer 4y to the power negative 4. But remember, we don't ever leave our answer having negative exponents. So then it means that we're going to apply what? We are going to apply the rules that we've learned, Laura. When a base is raised to a negative exponent, what happens to that particular base? We move it from the numerator to the denominator, and then the sign of the exponent does what? It changes. So what would we have said here? Is this negative exponent affecting 4? No, it isn't. So 4 remains in the numerator. Who goes down? I'm going down. He goes down. Okay, you see this thing of surrounding yourself with this negative exponent. Who gets affected? Y gets affected. How? Y changes position, the exponent sign changes to positive. So this would be our answer, Laura. Had we had y to the power 8, which is bigger than the exponent in the numerator, we simply apply the laws of exponents and we get to the answer. Hopefully that helps answer that question that was asked by Karen. Sorry, Karen asked that question, and I hope Karen is clear. Karen, are we clear? Clear? I hope we are. Okay, I think this will be my... Yeah, let's see if we can't do these last few questions. You're welcome, Karen. You're welcome. Right, simplify. Look at this one. The square root of 4x to the power 6 y to the power negative 2. Sorry guys for all of this writing. This was another learner. I took someone's papers booklet from last year. Right, you see this was the booklet, because they get booklets, guys. Okay, yeah, please guys, you will get this 15 minutes reading time before you start. Use this 15 minutes reading time to basically make sure you go through the paper. All right, I think in that 15 minutes reading time, you could actually make it a point that you get some of the answers for some of the questions, and it makes life very easy. I hope that makes sense. Okay, so there's the question. Square root of 4x to the power 6 y to the power negative 2 times x to the power 2 raised to the power negative 2 over 2x. 2x, all of him is inside the bracket, 0 is outside as the exponent, times y to the power negative 3. Okay, guys, I think this will be our last question. Okay, I'm going to do this as our last question because I have to leave at just before 7 so that I can head over to work. Thank you for the follows, guys. Thank you for those that have been sharing the live. You guys have been amazing. Thank you for the gifters. Really appreciate you. You mean a lot. Actually everyone who's been participating in some form, shape, or fashion. Thank you so much, guys. It means a lot. Okay, so here, how do we get to simplify this? Our laws, guys. You can see our laws are allowing our laws. Okay, so let's see, guys. Okay, my next grade 9 session will be tomorrow morning. Okay, and then I upload this onto the YouTube channel. I'll be finishing, guys, in the next 5 minutes. This is the last problem I'm going to do for the day. All right, and remember, we are still on question 18. All right, so for the first YouTube video that is already in my YouTube channel, I did question 1, but I was doing both paper 1 for 2023 and paper 1 for 2024, but we did question 1 up until 10 roughly. Okay, for the first video that I did. In fact, sorry, question 1 up until 8. Today we've looked only at 2024 and we've moved from question 9 up until 18. So I'm going to try and fit in another session, maybe this afternoon or maybe this evening for grade 9, so that we can push and at least we can have the sessions loaded there on my YouTube channel. If you are wondering about the YouTube channel, link is in my bio, guys. Go there to the link in my bio. You can go there, copy and paste the link, paste it in your Google search engine, press enter, search, and go and subscribe, and then also hit the notification bell so that the next time I upload the video that I did here, you can get it there. Right, 2x all raised to the power 0 times y all raised to the power -3. So once again, our laws, okay, are needed here. But let's check this out. In the numerator, relationship is multiply. In the denominator, relationship is multiply. There's no addition or subtraction, so that makes life very easy. So we know that as we look at this, we are going to apply BEDMAS, of course, brackets, exponents, division, multiplication, addition, and subtraction. And then in situations where we need to, S and L will definitely be playing his role. So look at this first one. The square root of 4x to the power 6, y to the power -2. Remember, when we apply the square root to this entire thing, because it's multiplication, we can say the square root of 4, the square root of x to the power 6, the square root of y to the power -2. You can split the square root for multiplication. For multiplication, the square root can be split. For division, square root can be split. But for addition and subtraction, nonsense. We don't ever split for addition and subtraction. I just want to show you what I mean by this. This is what I mean, guys. Law can be done. For multiplication, we can split. Law can be done. For division, square root can be split, or the root can be split, whatever root it is. 3, guys, for addition and subtraction, it's absolute rubbish to split the root. We don't do it for addition and subtraction. It's nonsense to do so. Okay, we don't do it. It's wrong to do it for addition and subtraction, but for multiplication and division, you can do it, guys. Okay, yeah. So let's come here. I split. Okay, look at that. Laws of exponent, guys, can be applied there. I hope you can see that. Look at this. Laws of exponent. Everything in the bracket is raised to the power 0. So what is that equal to? Guys, you don't need me to tell you that. You know, times y to the power -3. Now, what's the square root of 4? It is 2. X to the power 6, the square root. Guys, please understand this, that x to the power 6, the square root, you remove the square root, you say 6 divided by 2. Why do we say 6 divided by 2? Because the square root, there's this law that says, this one. When you have a root, the nth root, you can actually write this as x to the power m over n. you change the root to exponential form in this way. So the square root means there's a 2 here. So we can say x to the power 6 divided by 2, right? Because the law says so. Does that make sense? The law says so. The law, not me, the law, the rule. So in the same way, square root of 4 is 2. X to the power 6 obviously will be 6 divided by 2. What's that? It's x to the power 3. In the same way, square root of y to the power negative 2, that would be y to the power negative 2 divided by 2. What does that give you? Y to the power negative 1. So that becomes y to the power negative 1 times laws, guys, laws, x to the power 2 raised to the power negative 2. We multiply the exponents that give us x to the power negative 4. Laws, guys, laws. Okay, 2x to the power 0. Everyone is raised to the power 0. We must check who is exposed to the exponent 0. It is the sign, what, positive. It is the number 2. It is the x. Everyone is exposed. So if he is exposed, it means anything raised to the power 0 gives us y times y to the power negative 3. Now, since the relationship here between the bases and the numbers is divide and multiply alone, then S and L can be applied very smoothly. So let's first focus on the numerator, and then we'll come to the denominator and apply S and L where applicable. So here we are going to multiply this. 2x to the power 3, y to the power negative 1 times x to the power negative 4. So if we are multiplying, we first look at the sign. This is a positive times a positive, so that means the answer is positive. Sign is taken care of. We go to the number. 2 times this here is 1. 2 times 1 is 2. Number is sorted. We go to the letter. X to the power 3 times x to the power negative 4. That is x to the power 3 plus minus 4, which I'm sure you can get the answer to simply without even having to say 3 plus minus 4. I am showing you the steps so that you can see what I did. The bases are the same. I am multiplying. So what do? I keep the base. I add 3 plus minus 4. So that's why I say plus and then in brackets minus 4. The y is alone. So y to the power negative 1 stands next to the x. The letter is sorted in my numerator. I go to the denominator now. What's 1 times y to the power negative 3? Remember, 1 is like the Holy Ghost, angels and God. You just leave the y raised to the power negative 3 in the denominator. Then to finish off, very nice. Remember, S and L, we have sorted it out in the numerator, we sorted it out in the denominator. We multiplied the sign, we multiplied the number in the numerator, multiplied the letter. We are in this situation. Now we can say 2x. What's 3 plus minus 4? The positive times the negative gives us a negative, so 3 minus 4 is negative 1. Y to the power negative 1 over y to the power negative 3. Now, top to bottom, we can still apply who? Mr. S and L. Mr. S and L is crying for our attention. So if we look at this divided by that, we have one term in the numerator, the number, the sign, the number, the letters. In the denominator, we have one term as well, the sign, the number that we cannot see, the letter with its exponent. So now we are going to divide and still apply who? S and L. Guys, there's a reason why you get attracted to these kinds of movies. Now you need to not be attracted anymore. Do you know why? It's because you were supposed to be attracted to the maths, sign, number, letter. No more attraction to these nonsense movies, guys. Let's get the maths up and rolling. So if we now, S means sign, we divide the signs, we divide the numbers, we divide the letters. So let's look at this. The sign of this term and this term, it's positive divided by positive. We know we are going to get a positive outcome. The number 2 divided by 1, that is actually equal to 2. Okay, 2 divided by 1, guys, is 2. The letter x to the power negative 1 does not have a friend in the denominator. So x to the power negative 1, we are going to keep as x to the power negative 1 in the numerator for now. y to the power negative 1 divided by y to the power negative 1. That's another letter that we can divide. Y to the power negative 1, the bases are the same. We are dividing. What do we do when we are dividing same bases? We keep the base. In the numerator, we subtract -1 minus 3. Now, some of you are like, huh? Yes. -1. Obviously, we would subtract these exponents. But remember, this exponent is negative. So we are subtracting a what? A negative exponent. So this is 2x to the power negative 1 minus 1 plus 3. Minus negative times is positive. Final answer. 2x to the power negative 1. What's minus 1 plus 3? It is 2. Now someone will think, I'm done. No, you are not done. Why? Because, guys, because the exponent here is negative. We can't have a final answer with a negative exponent. So what do? 2 stays in the numerator. Y squared stays in the numerator. What happens, guys, to my x to the power negative 1? Remember the law? We said whenever a base is raised to a negative exponent, the base changes position. It is in the numerator. It changes position. It goes to the denominator, and its exponent changes from negative to what? To positive. So that 1 is there, even if we don't see it. We know it's ever present, ever ready, just like the what? I've explained to you guys many times. That is our answer. Done. Finished. That is simplifying of that particular exponent. So I have explained this to you step by step so that you are not confused about what you ought to do. That's it, guys. So let me end my live here at this point. Thank you so much to those that joined. So we have now covered, for the first part of the GEC section, we've covered numbers. Part 1, number systems, financial maths, direct and indirect proportion, rate. All right. You can check those, guys, in that part 1 of my video that I did yesterday, the live session. You can find it in the YouTube channel. Please go and check it out there. Okay. And then this part 2, I'm going to upload as I basically move. Hopefully I can get it uploaded before 9 o'clock. So I'm going to actually now leave you guys. Thank you so much for joining. The pages that I've written in, I'm going to take pictures of them and upload it on the TikTok page for you guys so that you can have, all right, so that you can be reminded, some of you who were here. But if you can go to my YouTube channel, as I said, go and subscribe, hop on there, then you can actually watch this again at your own time, at your own pace, according to what you want. Thank you so much, guys. It was really good being with you. And thank you for those that were participating so nicely. Thank you for the gifters as well. And thank you for everyone for just being here. It was great. And thank you for the follows as well. I really appreciate the support. Thank you. Goodbye until we meet again. Hopefully I'll see you today later on, this afternoon or this evening maybe. Guys, it will depend on my time, but definitely tomorrow morning. We know 5 a.m. Sorry, today I was a bit late because I woke up late, because I slept late, because some of you kept me up late yesterday. I'll see you tomorrow at 5:30 or at 5 a.m. so that we can continue with this. But if not, maybe this evening. Okay, this evening. Thank you so much. I have to leave because I can't stay.